So in this video, I want to talk about resolving forces on an inclined plane. But before jumping to that concept, let us first discuss a very rudimentary concept in geometry. That is, if we have two parallel lines and there is another line traversing these two parallel lines, then these two angles are essentially the same. Now, this is a very basic proof in geometry, but for those who are not familiar with this, I would still like to prove this out. Okay, this whole angle, this is just 180 degrees, right? So, what I can say is that 90 degrees plus theta plus alpha is equal to 180 degree. This implies alpha turns out to be 90 minus theta. So alpha is 90 minus theta, and therefore if this angle is 90 minus theta and this is a perpendicular, then this angle must be equal to theta, because the total sum of all the angles inside a triangle must be equal to 180 degrees. So what we have proven? We have proven that if we have two parallel lines and there's a line traversing these two parallel lines, then if this angle is theta, then this angle is also theta, right? Now, how does this help us in decoding the forces along the inclined plane? Let's see. So if we have an inclined plane, then I can just drop a perpendicular over here. This angle would be 90 degree. And we assume this angle to be theta. In such a case, this angle becomes 90 minus theta, right? Now, if you have a block over this inclined plane with mass m such that the weight of the block acts directly downwards towards the inclined plane, then this weight vector is going to have two components, right? The first component would be just perpendicular to the inclined plane, which is going to be this one. So this angle is going to be 90 degrees, and the other component would be along the inclined plane, right? So this is going to be the horizontal component, or we can call this as mgx, and let's call this as mgy. Now notice one thing. These two are the similar parallel lines that we encountered earlier in our rudimentary geometry proof, and this one, the surface of the inclined plane itself, is the traversing line that traverses these two parallel lines. So if this angle is 90 minus theta, then this angle right over here, it is also going to be 90 minus theta. And therefore in this triangle, if this is 90 minus theta and this is 90 degree, this angle must be equal to theta. So now that we have figured out what this angle is going to be, resolving the forces along the axis is going to be pretty easy, right? And notice one more thing, that I'm not taking the usual axis, that is the vertical axis being the y-axis and the horizontal axis being the x-axis. The notion of axis is somewhat different over here. Look, while solving the problem of inclined plane, it is preferred that the acceleration of the particle or the block must lie along the axis, or must lie at least along one of the axes, right? So in this case, we can see that the acceleration of the block is going to be downwards, and therefore we are choosing an axis in such a manner that the x-axis lies along the inclined plane and the y-axis lies perpendicular to the inclined plane, right? So this is going to be the x-axis, this is going to be the y-axis. So you can see that the force mg itself does not lie along any of the axes. So it must be resolved along the x-axis and y-axis in order to proceed with the solution of the inclined plane problem. In this case, the component mgy acts along the y-axis and the component mgx acts along the x-axis. Therefore, I can just extend this and drop a perpendicular right over here, right? In this scenario, we can see that the angle theta and the perpendicular rests on this side of the triangle. Therefore, this becomes the base, this becomes the perpendicular, and this becomes the hypotenuse. Now, if we go on to resolve mgy, we can see that mgy lies along the base, and therefore I should use cos theta. Now, cos theta is equal to base upon hypotenuse, which in this case, cos theta becomes mgy upon the hypotenuse mg. This implies mgy equals mg cos theta. Now, as far as mgx component is considered, I can either do complicated geometry and figure out what this angle is, or I can simply draw a parallelogram and make these two sides equal, right? The opposite sides of a parallelogram are always equal. So either I figure out this, or I can also figure out this. These two are going to be similar. So let's try to figure out this. Like, if we have this as the perpendicular, then we can see that mgx lies on the perpendicular, right? So I'm going to use sine theta as the formula. Sine theta is going to be perpendicular upon hypotenuse. This implies, in this case, sine theta just becomes mgx upon the hypotenuse mg. This implies mgx is equal to mg sine theta. Therefore, we have resolved the forces along the inclined plane, and we figured out that the x component of the force is going to be mg sine theta, and the y component of the force is going to be mg cos theta.